Hey everyone, welcome back to the program. And today we would like to introduce some of our key partners. Really a very brief introduction about what QSL is all about, what the team has developed so far, and what are some opportunities for all of you to get involved and participate in some very exciting projects we are building with some industry partners and fellowship opportunities for the best participants out there. My name is Vardaan Sahgal. You have been listening to me for quite some time now, but for those who are not aware, I lead the quantum software and solutions team here at Womanium Quantum, and my background is in atomic physics, but also quantum computing. With quantum at Womanium, we started off by identifying where all quantum computing is beneficial, and as might be the case with you, you must have already understood that there's not a very small domain or industrial use case where quantum might be applicable. Quantum computing is a new way of computing, and it is by far uh, targeting different industries across different domains, be it finance, optimizations, like we are working with Fraunhofer, or nuclear and pharmaceuticals and material science, as we talked with NNL, but also other areas like cryptography, data science, machine learning. So there's a lot of wide variety of areas where quantum computing has its effects. And I'm pretty sure that in the future, uh, regardless of where you end up working, quantum computing will have a significant impact on the type of work you are involved in. So, with that in mind, we wanted to teach and make sure that this education for quantum is available and accessible to all. We started creating the quantum computing program, running it successfully, touchwood, for the past 3 years, a huge success so far. And we wanted to take it a step further. So, not just educating and training all of you into the fundamentals of quantum computing, we also wanted to create an opportunity where you can actually build on real world problems, projects which are applicable in the real industry. So, you learn at one stage, but also apply your skill sets in the very next stage. And that is where we initiated a program called as a Quantum Solutions Launchpad, or QSL as we call it for short. We launched this thing last year, and we ran it as a pilot phase just to see how it goes, what is the experience so far, how the participants are engaging, how the industry is benefiting from it. And so far, this has been a huge, huge success. And we are very motivated by the response we have received. So this is basically a program where we target and select the best participants from a training program. So over the course of the summer, you have many modules to cover, many assignments, many quizzes to cover, and we will be monitoring all of that. And at the end, there's a capstone project for all of you to try on your own. So again, we'll be monitoring and selecting participants based on that. Overall performance throughout the entire summer program, we will select the best students, best participants, regardless of your education background, whether you are an undergraduate, a high school student, PhD, postdocs, or even industry professionals. If you are some of the best participants in a program, you will be selected. And you will be selected to partner with us, work with us as fellows with some very amazing organizations. Some of the organizations are listed here, but there are many more to work on very, very exciting research projects with the industry, with national labs on real world problems. Throughout the entire QSL program, you would be mentored, guided by some industry experts. You actually get the chance to work with some of the best minds in the quantum industry today. And some of the highlights of the past year, there are very exciting projects we have accomplished. I have listed some of them over here, up to 90% cost reduction in quantum chemistry algorithms, 66% acceleration in warehouse operations, and much, much more. Some of the pictures are over here. I may not have the time to cover all of these topics today, just because of the interest in time, but I would still like to dive a little deep into some of these projects to give you a flavor of how the participants performed, what was involved in these projects, and how the results were received by the industry. So, starting with that, one of the projects I would like to introduce you to is warehouse optimization using quantum annealing. And this is very similar to the training you all have already received from past week's lecture on quantum annealing with D-Wave and Q-Cobalt lecture series by Q-Bolt. So look at this picture of a warehouse. It's a very standard warehouse at Amazon, a huge, huge, like 3.6 million square foot warehouse. This is humongous in size. And it is practical, very difficult to find each and everyone's parcel in a stipulated time frame. Within 2 hours, if you want your delivery to reach your home, the process at the warehouse should be instantaneous. Order comes in, the robot picks up your parcel, your item, and straight away ships it to you. And to find one item in this huge warehouse is pretty big task. Automated did make our lives easier, but even automation has some difficulties. One, for example, is figuring out which robot picks which shelf and to which picker does it allot to. This mathematically is considered as a quadratic constraint binary integer model, which is NP hard. So the computational difficulty does not make it easier for us. And this is one of the motivation which prompted us to start looking into quantum and can quantum computing or quantum annealing processes be implied to warehouse optimizations. The team worked on it for roughly 4.5 months and tried using different approaches, pure quantum annealing approaches, a hybrid solver for CPU and QPUs, and benchmark it against the classical CPUs. Not only did the team did a really tremendous job on using the quantum annealing algorithms for solving this problem, but they also benchmarked it against some of the classical industry standards. So you can look at this chart, and you can look at this chart more clearly once the recording is posted. You can see that the yellow bar on each of these graphs is the one quantum annealing solution developed by the team. And it is continuously maintaining the least amount of time required for optimizing the warehouse operations in different kind of warehouse sizes. So be it a small warehouse, be it a large one, the algorithm which the QSL team developed over time using a D-wave annealing model was performing better than the classical counterpart. You can get your own inferences from this chart, but just a high-level insight, the entire operation was 66% faster than the classical counterpart, and this is like a huge achievement. So very motivated, very proud of the achievement this a particular use case had, and this is something which you can also start doing on your own. You have already learned quantum annealing, you have already gone through the basic lectures and the fundamental courses. Now it's up to you to start using your skill sets, your tools, to do something on the quantum annealing side. Another project I would like to highlight today is about QKD. And QKD is a little bit different from quantum computing. We haven't talked about in this year's lecture, but this was a huge component of our entire summer program last year around. QKD, for those of you who do not know, stands for quantum key distribution, which basically provides a way of distributing and sharing secret keys that are very necessary and significant for cryptography protocol. Why do we need cryptography protocols? To make our data safe. Why do we want to make our data safe? Because data is very important for communications as well as in storage in a variety of applications, from banking to business to health. There's a whole lot of stuff going on in the data science, data security space, and we need to protect all of it. QKD is one of the ways where we can make it quantum secure or quantum proof. Now, it would be very difficult for us to start encrypting each of the communication lines and start encrypting everywhere the communication channel is present. But it would be far more easier if we could just somehow make the satellite communication quantum encrypted itself, because that would just mean that we are encrypting long-distance communication right at the source, and that would solve a large amount of problems related with data security. Seems like a very fascinating use case, but this was not easy, and this is still a work in progress. But the team has been able to design a very compact and stable architecture for photonic chips for QKD. The end goal is basically building out a chip that is resistant to the environmental stresses, which has a very good photon pair generation and entanglement rate, putting it onto a CubeSat and launching it into the space to have a quantum secured network within the satellite. This is a very amazing project we are doing with Pramatra Space, a space organization. And yeah, for those of you who are interested in QKD, quantum communication, quantum cryptography, stay tuned for the space. There's a lot of exciting announcements coming your way. Another project I would like to talk about, and this is something which Brian shared at the NNL talk he just mentioned, was about using variational quantum algorithms for solving Poisson's equation. Poisson's equation, for those of you who are coming from a physics background, are well aware of that. But those of who are not, this is basically a differential equations for a lot of physical problems. In its essence, it's not that difficult, I would say. But still, this is very important for us, because if we can understand how to tackle Poisson's equations, or probably how can we understand quantum algorithms simulating the solutions for Poisson's equations, we have a very good chance at solving some complex differential equations as well. Perhaps something like Navier-Stokes for improving the efficiency of CFD simulations and whatnot. So this is like the first step in a long staircase of solving differential equations. And the work on Poisson's equations has been in process for the past decade or so. So it's not a new thing, but we reviewed all the stuff that has been going on when we realized that there's still a lot of room for improvement. And how do we efficiently simulate Poisson's equations and potentially simulate CFD using quantum computing? One of the target areas where the team focused on was if we can find an ansatz that expresses the solution of the Poisson's equation efficiently, we are already halfway through. So this is something the team focused on, and they started working on how do we find the best ansatz. Are the tensor network ansatz also a good solution? The team did some tremendous work on this. I won't go into the technical details because that is something the team would cover in some of the future lectures in the summer program, but just some highlights. The results based on the simulations helped them win up to 150,000 USD from the UMD QLab grant, which was huge. The INQ team was really fascinated by learning what the results were on the simulator side, and they really wanted the team to go a next step and perform the same type of calculations on real quantum hardware. So this was a huge, huge boost for the entire team. Not only winning the grant, their team also was invited to present their scientific posters at the PQI Quantum Symposium. Some of the pictures you can see on the screen at your right. And they also had the opportunity to visit the NATA lab. I posted the link down in the in the slide right at the very bottom corner. You can go to the link and read more about what the entire visit about NATL was. And yeah, if there are any questions, please feel free to pop them on Discord. I'll be happy to answer them. One final use case and project I would like to talk about today is on the quantum hardware side. A lot of software talk, but moving on to the hardware side, this was focusing on quantum sensors based on NV diamond center technology. So quantum sensors, for those of you who do not know, is improved, I would say, sensor, which is very important to get a high efficiency of detection of data from a variety of sources. Last week, we also had a lecture from NIST on the variety of qubit modalities. One of the modalities mentioned was NV diamond center. Why was it important? Because it can behave as qubits even at room temperature. And not only does it behave as qubits, it also helps scan NV magnetometer. So the quantum sensor as a magnetometer is one of a very widely researched topics today, but this is huge. Like you can see in the picture on the right, this is huge, this is very costly. So the goal of this entire project was to, can we make these sensors portable? Can we make them compact so that they can be used for a wide variety of applications? And the team not only did it make it portable, they make it small, they made it light enough to be carried by hand, they also reduced the cost of this entire sensor to less than $1,000, which is huge. And they went a step ahead and made sure that all the parts and tools used in building that sensor was out of common commodity and resources that are available to hobbyists and schools, so that everyone has a chance of building their own quantum sensors. And now the efficiency of detection might not be up to the industry standards over here, but that's a separate issue. At least now the quantum sensors are being available for testing and educational purposes to anyone and everyone. Next step, the team is now trying to make everything open source. You don't need to go through different paywalls trying to access how the quantum sensor is built. Everything will be available to everyone. And then you have a chance of building your own quantum sensors, probably at a lab, but very soon at your own garage too. And yeah, this team was invited to meet the director at the National Energy Technology Lab, Marianne Wilk, and present their latest work to the team. They also presented their scientific posters at the PQI Quantum Symposium. Angeli Torno, one of the QSL fellows involved in this project, was invited to speak at the Quantum Tech Industry Conference as well in Washington, D.C. A couple of months back. Again, I posted a link down in the slide deck. Once this recording is available on YouTube, please feel free to go through the link and read more about the project. And finally, a huge, huge shout out to all the QSL fellows who have been working with the Womanium team. I would like to personally thank every one of them: Ron, Angeli, Horia, Mandy, Feroz, Erica, Valerie, Mohammed Nasir, Nasser, Abdullah, Morse, Yuri, Alfia, Alberto, and a few others. Thanks a lot for this entire QSL program. This would not have been as successful as it is without you guys. So you did a tremendous job. It's still continuing, and we expect a lot of more from you guys today to participate in the QSL program. So I would expect some of the best participants today in the Discord chat, learning about the quantum program, to be involved with the Womanium team and work on some very exciting projects in the days to come. So how do you get involved? Today is June 17th. So today was an introductory session by the partners. You heard a lot about what NNL is doing, what Fraunhofer is doing. And next week, Monday on June 24th, you will learn a little bit more about what the projects are for this summer. A lot more details will be shared, participation guidelines, how can you participate, how do you build a solution, how do you form teams. Everything will be shared in detail next Monday, so do not miss that session. From July 5th to August 9th, you all will be forming teams on Discord. Every project has a specific team guideline on the number of people who can be in a team. So make sure you very clearly understand what is required in a project before teaming up, before starting working on any project. And for this entire period, you are, working on a project. The entire QSL team will be available for guidance and mentorship on Discord. So if there are any questions, technical or organization related, please do not hesitate to contact us. We are very, we will be very happy to help you out on any kind of project related issues. On August 15th, we'll have the demo day where the finalists and all the teams will be presenting the solution. This will be a very short business-oriented presentation, 5 to 10 minutes max, just describing what the problem solves. And based on your technical deliverance, on your presentations, awards will be announced. So on August 15th, we'll be announcing all the awards, all the prizes people have won to all the participants. And the selected few participants will be shortlisted for QSL fellowships, and the fellowships will be starting from September 1. So this is a brief timeline. You can take a snapshot right over here as well, but otherwise, again, this will be put on YouTube, so you can refer to it over there as well. And with that, just shout out to all of our key partners for 2024, the US Naval Nuclear Lab, Fraunhofer Institute from Germany, and Classic, a quantum computing company from Israel. They all are our key partners. 3 projects will be hosted in collaboration with these 3 key partners, and there will be fellowship opportunities, awards, many prizes from the Womanium team waiting for you for these projects hosted by these partners. So stay tuned for the projects. I'm personally very excited, and I'm sure you two are. Before wrapping up, a huge shout out to the Womanium QSL team. Thank you everyone for being there, for supporting this entire initiative. And if there are any questions, you can reach out to me, but you can also reach out to any of the others. Jasmine, you all have already seen her very active on Discord. So thank you, Jasmine, once again for helping out there. But otherwise, if there are any project-related queries, please feel free to shoot them to me or Brakao, Horia, Prati, or Raj as well. And with that, thank you everyone for today's session. Stay tuned once again for the project information and all the participation guidelines on next Monday, that is June 24th. Do not miss the live session then. If there are any questions or queries, please feel free to post them on Discord. My Discord handle is listed over there, but otherwise, if there are other questions or queries not related to the project, not related to the Womanium program, and if you're interested in any kind of project collaborations, I'm also available over LinkedIn or mail as well. So thanks a lot, everyone. And I'm very excited and eager to meet some of the exciting fellows coming from this cohort and working with you all. Thank you, everyone.